We're checking to see if these are arithmetic sequences, and if I look to go from 1 to 4, I would be adding 3, or 4 take away 1 is 3. To go from 4 to 9, I'm adding 5. So right away I know this is not arithmetic because I need to be adding a constant amount to make it a linear relationship if I were to create a table of values. So this one was an add 7 here. So this one's not arithmetic, and we're done. We're not going to find its general term. I mean, you can if you want. It's not a difficult one, but it's not a linear function or a linear relationship. It's not arithmetic. All right, so we want to check the next one, and it's a little bit unusual looking, but I know that to get my differences, I'm really subtracting my one term from the one before it. So I could take my second term, which is 3x, and subtract x, and 3x take away x is equal to 2x. Okay, and then if I take 5x's, and I subtract 3x's, 5x take away 2x, or 3x is equal to 2x once again. So it looks like I do have the same difference. It looks like I'm just adding 2x's every time to get from one term to the next term. So my d value is just going to be 2x, okay, or my common difference, or my slope is really a 2x on that one. All right, so I need to come up with my general term for that particular relationship. And to do so, I could use my formula like I have before. My first term, my a value is equal to x, and the d value is equal to 2x. So by the formula, term n, it's equal to a plus d times n minus 1. Okay, so my a value is x, my d value is 2x, and that needs to multiply and take away 1. And if I expand that, we have 2nx, and then take away, or 2xn, it doesn't matter how you write that, take away 2x. And then if I add x and I take away 2x, that's going to have negative. So I could have 2xn or I could have 2nx, it doesn't really matter. And then take away x. So that term, n, any term can be generated by taking its position number, timesing it by 2 and x, and then taking away x from that. Okay, if I wanted to look at the other method of doing that, I know my slope would be equal to 2x, and if I work backwards, if I'm at x and I take away 2x to work backwards, that would give us negative x. So my a value, or my y-intercept, would be the negative x, and my slope is my 2x. So hopefully that makes sense. All right, question number 2, determine the number of terms in the finite arithmetic sequence. Okay, so the number of terms, we want to know, this is finite, we have a last term right here, so term n, we don't know n, is equal to 123. Okay, so what I'm being asked to solve for is what is our value of n? How many terms are there in that sequence? Now, if I look at this, I can figure some things out here. It looks like it told me it was arithmetic, so I know that I should be adding or subtracting a constant amount every time. So it looks like I'm adding 2. 3 take away 1 is 2. 5 take away 3 is 2. So I know my common difference is equal to positive 2, or my slope is positive 2. So if I go with this formula for my arithmetic sequence, I know that term n is equal to a plus d times n minus 1. And what I want to do is sub in what I know and solve for n. I know term n. I know term n has a value of 123. So my Tn is equal to 123. My a value is my first term, which is a 1. And to it, I'm going to add my d value, which is 2, times n minus 1. So this is where our formula comes in handy in terms of being able to work our way through this more quickly than if I were to just use my y equals mx plus b. All right, I just need to solve this for n. I could subtract 1 from both sides to get rid of this. That takes me down to 122. So 122 is equal to 2 times n minus 1. I have a couple options here. I could expand this, the 2 through the bracket, or I could just divide both sides by 2 to get rid of it. That will cut my number down more quickly. That should be a 61. A half of 122 would be 61. That's equal to n take away 1 now. And to get n by itself, we're going to add 1 to both sides. To undo that. So 61 plus 1 would be 62. So there are 62 terms in the sequence. All right, so therefore there are 62 terms in the sequence. Okay, so hopefully that makes sense for you. Sorry, that's really terribly messy, but hopefully you heard what I said. There are 62 terms in the sequence. All right, let's move on to our next example here. All right, part B. I want you to take a look at that. See if you can figure that out. Use the process we've just talked about. Put the video on pause, try it, and then you can check it out. See how you did. Okay, hopefully you tried this out. Put the video on pause. It looks like we're going down 4 every time here. So my common difference is actually -4. D equals -4. The A value is 21. And if I sub that into my formula, term n is equal to A plus D times n take away 1. My A value, my term n is -35. My A value is 21. And I'm going to have take away 4 times n minus 1. We could either expand, simplify, or we can start to isolate. It's up to you. I'll do this one with the expand and simplify, just to show you you can solve it that way as well. Expand that -4 through the bracket. You're going to have -4n and a +4 here. 21 plus 4, if I combine these like terms here, 21 plus 4 is 25. So I have -35 is equal to 25 minus 4n, and then we can start solving for the n, isolate the n. I'm going to subtract 25 from both sides. 35 take away 25 would be -60. -35 take away 25 is -60. That's equal to -4n. And then to get n by itself, divide both sides by -4. N should equal +15. So there's going to be 15 terms. Now, if it's a true sequence, your n should always be a natural number. It should be a number that's whole, no parts to it, and positive. All right, so therefore, there are 15 terms in the sequence. Okay, so our little formula, even though it seemed like it wasn't useful at the beginning, it does make our work a little bit easier when we are trying to figure out things like this. Example 3, determine the general term for the following arithmetic sequences if, and now I've only given you 2 of the terms in the sequence. Okay, the first one's not too bad because I've given you 2 terms that are side by side here. Okay, so I know that term 3 has a value of 7 and term 4 has a value of 10. That means to go from term 3 up to term 4, we're adding 3. So our D equals 3. We don't know our A. A is unknown. So we got to kind of work towards that. I could work backwards because I'm at 3 and 4. I could just say, well, term 2, I could subtract 3, and that would give me a value of 7 take away 3 is 4. So term 2 would be 4. I could subtract 3 again to get down to term 1. And subtract 3. That will take me down to a 1. Okay, so this is easy enough because you are only like 2 terms away from term 1. So A we can figure out pretty quick. It's going to give us a value of 1. If I gave you like term 67 and term 68, it's going to take a little bit more time to get there. So again, you could use your general term equals A plus D times n minus 1. And you can sub in what you know. I know for the third term, let me use a different color here, the third term's value was 7. So term 3 had a value of 7. So term 3, if n is 3, so what I'm using here is n is 3. So that's telling me that term 3 is 7. And then I would have A plus my D value is 3 times my n is 3, 3 take away 1. And then I can just solve that for the A. A equals, Bedma says do what's inside the brackets first. 3 take away 1 is a 2. That gives me 6 there. So 7 equals A plus 6. Subtract 6 from both sides, and we get A equals 1, just like we had predicted. So if I had the 66th and 67th term, or the 67th and 68th term instead, this would be a much quicker way to figure out your A value. Okay, so your general term then, your Tn would equal 1 plus, the D is positive 3, times n take away 1. Now when you look these up in the back, you're going to see that they are in their simplified, like linear form. So I would actually have 3n here. Oops, I'm just squishing that in here. Let's see, 3n. That would be a -3, and then -3 add 1, that's on the front. -3 add 1 would be -2. You're going to see it written in its simplified form when you check those. All right, now my next one, I've got term 5 and term 9. These are not side by side, so you could think of this kind of like a table of values here. Term x, or you can think of this as your n and your tn here, your x and your y, or your n and your tn. You have that term 5, so when n is 5, the term 5's value was 6. And when n was 9, the term 9's value was -14. If I do the difference in my y's, this would be like my y2 minus y1. I then want to divide that by my difference in my x's, x2 minus x1. So you can either calculate them table of values wise, or you can do it using the slope formula to get your d value. This is going to give you your d. Your d is your m. It's the same thing as the slope. That's an arrow, by the way, if you can't read what that is. All right, so -14 take away 6, that's actually -20. -14 take away 6. It's going to be -20. And on the bottom, we've got 9 take away 5, which is going to give us 4. So -20 divided by 4 is equal to -5. So we're actually subtracting 5 each time here to get there. All right, so there's my d value, and then you can go ahead and solve that for the a value. All right, in the end, I believe I have done a solution up for this, or not. I don't know where I put it. Let me see what I got on my sheet here. Yes, I did. Okay, in the end, you can put this video on pause and try it out. I'm just, for time's sake, because I'm going to run out of time for YouTube, it doesn't like it when these videos are extra long. So Tn, in the end, I believe I got it to be 31, take away 5n. And hopefully we match up with that. Okay, hopefully that makes sense. Go ahead and work on your assigned questions.